So table 2, what is my y value when x is -3? 0.
No, oh my God.
Well, let's see, because I haven't done the math yet today. So here's what it would look like in your calculator if you use Desmos. If you don't know how to use your calculator, just let me know. It's not a big deal. I didn't know how to use a calculator for like, I don't know, a while in chemistry, and I was always like wondering why I got the wrong answer. So don't be embarrassed. Like, we all have to learn how to use a calculator. We're gonna do well. All right, so that's what the answer is, right? Now, what about table 3? What is it when x is -2? -0.8. See what my calculator says. All right, so I would probably put a few more numbers there. If we're rounding, let's round to like the maybe 2 spots at least. And if I rounded 2 spots, then it's 0.89, right? Because rounding rules. If the number to the right is and I'm not looking at the right spot. If the number to the right of where you're rounding to is 5 through 9, you round up. So the correct rounding would be -0.89. So then I'll make this just 0.96 then, so that's the same. Table 4, what would be the y when x is -1? All right, let's see. And then we'll keep it rounding to the second spot, so -0.67. All right, anything to the 0 power is normally 1, but don't forget in this one, there's a few more things attached in there. So it's 3 to the 0 power, which becomes 1, and then it's -1. So when in doubt, just put in your calculator to be sure. So really that becomes 0, and there's also a -1 in the equation. Now graphing these so far probably won't give me much information, right? So I might need a few more x values just so I can actually see like that curve. And it looks like going to the left of the x-axis probably won't help me because they're all like really close together, right? So I'm gonna go and to the right of the x, so probably pick like 1, 2, maybe 3, we'll see. And then plug those in. Which if you have Desmos, it's really easy, you just change the exponent. So 3 to the first -1 gives me 2. That's a lot easier to graph. 3 squared is what? 9, and then -1 is, sorry, I put the wrong number. Yes, 3 squared is 9, -1 gives me 8 for my y value. That's probably good enough. I think if I put a 3, it'll be way off the graph. Yeah, it gives me 26. But that's a way you can figure out what x is doing. All right. Usually I'd say -2 to +2 is good, usually. So then if I graph -3 down almost -1, it would be there. -2 down almost -1 would be there. -1 down almost -1 would be there. 0, 0. 1, 2. 2, 8. And then the other one is way off the graph, so that's all that fits on. All right, connect the dots. It doesn't have any limitations. At least it doesn't tell us that there is, so assume that it does go on infinitely with the arrows. Yes. All right, is this growth or decay? Growth, because it is growing from left to right. Table 5, what would my domain be? Or tell me, what is domain referring to? All the x values. Table 6, does this graph look like it's going infinitely left? Does it look like it's going infinitely to the right? So then my domain class would be all real numbers, good. And just a little tip, for this unit, it'll be all real numbers the whole time, for the domain at least. It'll always go infinitely left and right, unless they say that it's like a real world situation, and like, there's no negative x's allowed. All right, but otherwise, it does go infinitely left and right. Table 7, what would my range be? Range refers to all the y's. Does it look like it goes infinitely up?
Yes.
Does it look like it goes infinitely down? So there is a boundary class on the y-axis, so I'm going to show that. Remember, we always did an inequality symbol for every boundary. Well, there's only going to be one boundary. So there's one inequality symbol. Where does it look like the graph kind of stops? What y value? Table 8. Oh. You can try to see it on the table or from the graph, or try looking on the table. What does it get close to but not exactly touch on the y? Sorry, look. So not in that direction, because it does touch the 26, like 26 is one of the outputs. -1 is what it gets close to without actually touching, right? Yes. Doesn't ever actually have -1 as an output for the y. So I'll show you, even when I make it like a smaller x value, still not -1. Still not -1, but it keeps getting closer and closer without ever actually touching it. So are these y values greater or less than -1? Tell me, table 1. So the question was, are these y values greater or less than the -1? Greater. Does it touch the -1? Does the line touch the -1? Or do these numbers touch the -1? No. So do not put a little line underneath, it's not equal to. Good? Okay. Table 2, what's my y-intercept? 0. That's where it crosses on the y-axis. It's also where x is 0, so you can see it from your table really easily too. And then my asymptote, table 3. Take a shot at it. Your hint is that it's really similar to the range. Yeah. Table 4, and the answer. Does anyone know it? y equals -1 is correct. All right, so really similar to the range. Only difference is instead of an inequality, we're gonna put an equal sign. So that it gives us a line that it gets close to without ever actually touching. So then when I put this in my graphing calculator, when you zoom in, it gets real close to the -1. It might even look like it's touching it, but it's really not. As you could see, like the more I zoom in, the more you see it never actually touches the -1. Good there? All right. We'll stop there for today, so don't lose your notes. You do have a practice though. So all the ones that have it as where the one with the exponent is a number bigger than 1, do those. So like, for example, on your practice, you would do number 5 right now. Would you do number 6? Yes, because the one with the exponent is that 2 bigger than 1? Yes. Would you do number 4 yet? No, because 1/2 is not bigger than 1. So don't do that one yet. I haven't shown you a decay one yet. Not that it matters, you should still be able to, but we'll just scaffold it if we have the time. Will you do number 7? Yes, because that one is growth. The one with the x. So remember, it goes y equals ab to the x. The b is bigger than 1. So do that one. Would you do 8? No. Not yet. Would you do 9? Yes. No, 2/3 is still less than 1. And then would you do 10? Yes. So just try all the growth ones for now. We'll do a decay example tomorrow and we'll pick up there. But just try those. If you have questions, let me know. And that should take us till the end of class. That's like 15 minutes.